Hello and welcome to the Daily Space. And we have audio. Hello and welcome to the Daily Space for today, May 28th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. For those of you who are new, we are a channel dedicated to astronomy, space science, and exploring the solar system we all share. When you sub, when you donate bits, when you otherwise do things to support the channel that we find out about in real time, just like that, we thank you by giving you a dose of cuteness with dogs. So we're also very pro-dog here. These are both rescue animals. Stella's the smaller, Eddie is the larger and fluffier. Right now, I am going to give you a rundown of the news, but before I get started doing that, I want to let you all know, in case you don't know already, that the OSIRIS-REx spacecraft needs you. If you go to bennu.cosmoquest.org, you can help us map out this super rocky asteroid. What we're working on doing together is finding, well, the safest places for our little spacecraft to touch down and grab a sample of the surface of this asteroid. All of the data that you submit is getting sent to the OSIRIS-REx team, and together we are working to keep this little spacecraft safe. It's hard work, it's tedious work, it cannot be done by a computer. It can only be done by us. And we have until July 10th to make it through all the images, and there's new images coming in every single day. And on July 10th, they're going to pick what are the best potential spots so that they can do further high-resolution imaging of those areas. So please, while you're listening to this show, in another window, click over to bennu.cosmoquest.org and get some science done. Now, the primary reason that we're here today is to bring you what's new in space and astronomy. Now, with the holiday weekend, there isn't a whole lot of news to share, but there's one story that really stood out as that's not quite what I expected to see in my morning space newsfeed. And this is a combined result of anthropology and astronomy all working together. In this case, it's been realized that, well, the ancestors of modern humans started to be bipedal, well, about 8 million years ago, 5 million years ago. And at that same time, sorry, I got those years wrong, started to be bipedal about 3 million years ago. I'm confusing the dates, reading my notes too quickly. So it's realized that the ancestors of modern humans started to be bipedal about 3 million years ago. And another thing happened at that time, and that's, well, our planet got bombarded with ionizing radiation from supernova that were going off in the region of the planet Earth. It's been recognized thanks to a deposit of iron-60 that is found in various geological sediments, that the only way to get this layer of iron-60 is if our Earth was near actively exploding supernovae, and the high-energy particles from those supernovae interfered with Earth's atmosphere and deposited this material on the planet Earth. These materials were deposited between 8 million years ago and less than 2 million years ago, with a peak in the amount of ionizing electrons coming into the lower atmosphere occurring about 2.6 million years ago. Now, all of this ionizing radiation coming into Earth's atmosphere didn't destroy our planet. It didn't really cause a mass extinction. But when this happened, we saw a change in our world. We went from what is geologically referred to as the Pliocene epoch to the last major ice age. And one of the things that triggered that occurring, we now think, is massive amounts of lightning that was triggered by having all this extra ionizing radiation in the atmosphere. And all that extra lightning lit fire to massive forests in northern Africa. This change in the environment from being primarily forested to being primarily savanna would have changed what it took for life forms to really thrive in that environment. Prior to all of this lightning taking out the forests, it would have been possible for the ancestors of modern man to basically climb up a tree, find what they needed, climb down a tree, scramble sideways a little bit, go up a new tree. Trees were close together. Food was readily gotten in the trees. You get rid of the forest, you move to having savanna instead, and suddenly you have to move great expanses between the trees. And this kind of need to go great expanses, well, the early hominid bodies weren't adapted to do that readily on four limbs. And the early humans at that point had the ability to either scramble on four limbs or walk on two limbs, just like modern gorillas and chimpanzees and orangutans. Well, all of the animals I just mentioned, they live in forests. Our ancestors that became bipedal lived in those savannas. And it is more effective when you have unequally sized limbs like they did to adapt, as is shown in this illustration, to walking on two limbs. So, looking at evolution, looking at the mechanics of a skeleton, looking at food sources, and looking at the ionizing radiation of supernovae, putting all of these pieces together, it looks like supernovae went off near the Earth. The ionizing radiation from those supernovae caused massive amounts of lightning. That lightning caught fire to the forests. The forests went away, leaving savanna. The early hominids that had been living in those forests didn't have trees to climb anymore, needed to walk great distances, evolved, became bipeds, and millions of years later, we have me stumbling to try and explain this on the internet. Thank you, supernovae. Yeah, that is one heck of a chain of events. Now, we don't have any way to go back and prove that this is true, but it fits the evidence, and it's a pretty awesome story. So I'm sharing it with you and kind of hoping it's true, because the idea that supernovae are responsible for so many different things, I just like that idea. Okay, on to things that are a little bit more close to home, and in this case what I mean is are in low Earth orbit. One of the great frustrations that a lot of people working in a variety of industries have is that combustion of different materials often leads to soot. If you've ever had a backyard fire, you know that wood doesn't completely combust all of the time. It leaves behind ash, soot, nasty, gross, incompletely combusted materials. If you burn candles in your house, will actually get soot build up on your walls. If you're a smoker, you know you end up with built up materials on your walls and in your lungs. That buildup of material is due to combustion being incomplete. And it's possible to sometimes get complete combustion. And the question has been, why is it sometimes materials combust completely and sometimes they leave behind soot? And there's been two different theories, both having to do with exactly how the gases involved in the combustion are mixing. Is this due to there just not being enough oxygen in the point of combustion at the point of combustion? Our atmosphere is a mixture of oxygen, which is needed for most combustion, and nitrogen, which is inert, and if you have only nitrogen, will safely put out a fire. So people have been trying to mix the oxygen, nitrogen differently in different kinds of combustion scenarios to get more and more complete combustion. But if this is the exact problem, well, we haven't been able to answer it here on Earth because flames rise, heat rises, this whole gravity thing makes it impossible to really get the kind of mixture we want. But in zero gravity, in still air, you get perfectly circular flames, as is shown here. And as terrifying as this is going to sound, there are currently experiments going on board the International Space Station where they are purposefully combusting things, small things in safe environments where there is no chance of like ruining the atmosphere of the ISS and setting the whole thing on fire, we hope. But they're trying to answer this problem. They're trying to figure out how to actually get sootless burning. Now, this isn't going to solve the problems of the industrial world. This isn't going to make coal any cleaner, but this will lead to some processes in chemistry hopefully being done more completely. Okay, so today's news from space science wasn't really rich in things revolutionizing our understanding of the universe, but it was still pretty cool. Tomorrow, hopefully, now that we're out of the holiday weekend, we will have more news to bring you, so stay tuned. And I am now here to answer your questions. So go ahead, type them in, and remember to type at CosmoQuestX while you're doing it. That will make your questions much easier to find. And while you're typing them in, I'm going to remind you, this is a production of CosmoQuest.org, your place to learn and do science. We are produced out of the Planetary Science Institute, a 501c3 nonprofit that is on a mission to help you understand our solar system and the universe beyond. This also means, because the Planetary Science Institute is a 501c3 nonprofit, that your donations are tax deductible where the law allows, which gets to the point that we are brought to you by you. We are here thanks to the generous contributions, the bits, the Patreon subscriptions, the subs here on Twitch of so many of you. And while your dollars are nice, it's also super helpful when you do things that don't cost money. When you do things like share what we're doing with your Twitter followers, with your social media, with your friends in the real world. Anything you can do to help bring more people to CosmoQuest really helps us out. Right now, as I said at the start of the show, we are in the process of trying to map out Bennu. And we need as many hands and eyes on this project as we can possibly get. So share the word, and together we can map out Bennu and find the place where OSIRIS-REx can safely touch down and grab a sample to bring back to Earth. I'm now going to scroll through the questions and see what I can find. And cough, because coughing. Okay. Hello, everyone who said hello in chat. And thank you, Veronica and Herleu, for the bits early on. Scrolling for questions. Nightbot is talkative today. So Larry Weird and Proud, Larry Weird, you shortened your name, asks, did you see Gravity? Was the depiction of the fire on the ISS accurate? So people who love me wouldn't let me watch the movie Gravity because they said I would shout at the television a lot. I don't know if that helps answer your question, but that is a true story. Yes, Veronica Cure, coughing is good. It's just I'm tired of coughing. For those of you who don't know, I was out for about 2 weeks with bronchitis. So it's good to finally be back. Okay, you guys don't have a lot of questions today. So I'm gonna answer. Oh, I'm sorry that you're coughing too now, Lady Pembroke. So I'm gonna do some marking of this asteroid. Your dad isn't allowed to watch Top Gun for similar reasons. That's kind of awesome. Okay, so I'm going to do a little bit of mapping and answer some common questions while I do. So one of the questions that we've been getting a lot is, what is the difference between boulders that we mark with the boulder tool, which I'm using right now, and rocks, which we use this little tool over here to mark? In general, what I've been doing is marking anything that is half the size of the rock tool to about 3 times the size of the rock tool with the rock. Now, the reason I'm not marking things that are super smaller, and thank you for the bits and the sub, the Robin Allen and Trekker Kev. Eddie always has this fantasy that he can catch things, and he can never catch things. Thank you so much. So I'm marking only things that are about half the size of the blue dot and bigger. The reason that I'm doing that is otherwise I would never be able to finish an image. This is also why you guys don't have the ability to zoom. If you had the ability to zoom, you would try to mark dust. This is human nature. We like to do things completely. And we want to make it so that you don't frustrate yourself and you actually get to finish things occasionally. So anything that is about 3 blue dots in size, so like this is about 3 blue dots, anything that's about 3 blue dots in size and bigger, I put a line along its longest axis. This, I'm not sure if it's 3 rocks or 1 lumpy rock. I'm going to be optimistic and assume it's 1 lumpy rock. And anything that is, like I said, smaller than 3 blue dots, but bigger than half a blue dot, I go ahead and mark. And sometimes it's hard to tell if something is on the edge of being a boulder or a dot. Just do your best. The way the software works is if people half the time mark something as a boulder, half the time mark something as a rock, we know it's a large rock. It all works out thanks to statistics. So thank you for the sub. So go out, go mark rocks, people. My dog is now staring at me like no dog has ever. Thank you, Bill Nash. Eddie, come here, Eddie. Sit. No. Here, look at here. Smell the camera. Smell the camera and be cute. There we go. Thank you, Bill Nash. And can we get a shout out for Bill Nash? He's another one of the educational streamers around here, and he does photography. His streams are just pretty to watch. If you need something to like zen out while learning more about how to do awesome photography, his stream is a good one to do that with. Okay, so marking all the rocks. Now, a bunch of you are like, why can't we just like have AI do it? Well, the thing about AI, artificial intelligence, is you need to have training data, and every world's images, every world's geology is just enough different that you have to train the AI over for each world. We trained an AI using data from the moon and tried giving it data from Mars, and it was just like, yeah, no, I can't do this. Since these are all brand new images of Bennu, we don't have training data. Now, it could be that someday all of the images that you guys are in the process of marking, and this is a giant boulder underneath, it could be that someday all the images that you guys are marking can be used to someday in the future train an AI. Right now we need to use your brains. So please let OSIRIS-REx borrow your brain and help map boulders and things on other worlds. Yeah, so many more images are incoming. I'm actually going to upload a set of images as soon as I'm done streaming. Now, it can take anywhere from 5 to 10 minutes to an hour to get through one of these images. It all depends on how many rocks there are to mark and how many large boulders there are to just take up space. Occasionally there are actually craters. They're really hard to see. We have asked the OSIRIS-REx team to change the contrast on the images, and they have promised to do so. So the images that you're working on should start having better contrast on them in the coming days. We're talking a lot about this on Discord. If you have ideas, if you want to ask questions, if you just want to yak while you're marking images, join us over on Discord. One thing we have noticed is sometimes the software gets confused if you have rocks right near the edge of boulders. If that happens to you, just delete the boulder mark, put the rocks in, go back. I can't tell if this is a bunch of rocks or a single boulder. The pixels on this image, each pixel is, I'm going to mark that as rocks. Each pixel is about 5 centimeters across. The reason I say about is we don't have a perfect shape model for Bennu yet, so the pixel size varies a little bit. We've corrected as best we can. Thank you, the better Owen, for the follow. But it's imperfect. So do the best you can marking things. Boy. And it's okay to curse rocks. I suspect by the end of this, there's going to be a deep-seated hatred of rocks in many of our souls. I think I'm already developing it. So yeah, join us over on Discord, help us map, and together we can get a whole lot of science done. And we're going to give everyone credit for the work they did. And everyone who signs up, we're going to be keeping you up to date through email with the solutions that we get from your data. So stay tuned, everyone. Results are coming, and the email I really look forward to sending is emailing people whose regions get selected for follow-up imagery because they just happen to be the person. Oops, I hit that bug. They just happen to be the person who found the region that looks safe and that we're doing follow-up imagery on. So, as I said, we have until July 10th. So get on it, people. Veronica Cure wrote, I ground a curved boulder yesterday. 1 mark or 2. You found, I'm going to guess, you found a curved boulder yesterday. I would mark it with only 1, so 1 mark per rock. One of the things that we are figuring out using the software is when we have a rock where everyone clearly marks the same line, that tells us it's a nice oblong rock. When we have things that, so on this rock, I could have marked this diagonal, I could have marked this diagonal. When we have things where people mark different lines, that tells us it's less oblong. So we're actually getting additional information from the differences in how people mark images. We're giving each image to 15 different people. Okay, so I'm going to finish this image up, and then when I am done, I'm going to upload new images into the system and work on an FAQ. And I'm also working on the next major version of the CosmoQuest software, which we expect to put open source this summer, so that when you guys have cool ideas for the code, we can say, here's our GitHub, help us make that happen. So thank you all for everything that you've done. Thank you in advance for all the images I expect you to map. And I'm going to release my dog's squirrel. She no longer cares. I'm going, there she goes slowly. Nope, doesn't care about the squirrel. I am going to go do more science. And yes, Michael Cassidy, it does look like it has an illness of some sort. So, I will see you all over on the Discord. Wherever you are in the world, have a fabulous morning, evening, afternoon. Let me know who you think I should raid. And I will be back tomorrow at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time, to bring you, oops, why are you doing this, Stream Deck? I will be back tomorrow to bring you more. It's still not doing it right. To bring you more of what is new in space and astronomy. And now for the credits. Bye-bye, everyone.